Let's look at the first FRQ. This says that the figure below the graph is the graph of f prime, which means that's our derivative. The domain of f is the set of all real numbers x such that they're in between -10 and 10. So that just means we have a graph that exists between -10 and 10. So let's look at our questions. Remember, this is an FRQ, so we need to lay out our answers very specifically. So A asks, for what values of x, so we're going to give some x equals, does the graph of f have a horizontal tangent? So remember, a tangent, slope of the tangent, is our derivative. So we have to think about horizontal. A horizontal line has a slope of 0. So this is asking, where is your derivative equal to 0 on this graph? So let's look at the graph. This is a graph of the derivative of f. Okay, so we need where the derivative is equal to 0. So on this graph, 0 is here. So my graph is equal to 0 at -7. That could be -1, or if you say like -1.5, anywhere in between there. It's a little bit hard to draw graphs, so the spots aren't on. So if you did put a decimal, that's fine. And 4, and I would call that anywhere between 7.5 and 8. So if you said any of those things, that would be correct. That's how they do it on the AP exam. Whenever they have something that's not exact, they give a window that is reasonable. So for A, we can say what values of x? X equals -7, -1, 4, and 8 has, so what values of x does the graph? So at x equals -7, -1, 4, and 8, the graph of f has horizontal tangents because the derivative f prime is equal to 0. Now I know that this doesn't say justify, but I usually err on the side of caution. If you know the reason, just write it down, because some years on the AP exam, they're more picky than others about how you answer and what your reasoning is. So just be careful there, okay? Now let's look at B. So we're still going to answer in x values. So in the interval, so we're looking from -10 to 10. So that just means basically we're looking at a graph. Does f have a relative maximum? So a maximum on our original graph looks like that. And it's when our derivative changes from positive to negative. So we are looking for a change from positive to negative. And this is a graph of our derivative. So you have to be really careful about what kind of graph you're looking at. So for B, we are looking for a relative maximum. A maximum happens when we change from positive to negative. So positive numbers are up here, negative numbers are down here. So there are only two places where this graph changes from positive to negative. And they're at -1. And if we follow along, this is negative to positive, so that is not a maximum, it's a minimum. Here's our other maximum, from positive to negative, so that's x equals 8. Or your decimal if you decided to use a decimal there, like 7.5 to 7.8 or whatever you decided to use. This one does say justify, so we must give an answer. The reason why is because our derivative changed from positive to negative. That is a definition of our maximum. So f has relative maximums, relative maximums at these, or maxima, that's our plural. They won't count off of that on FRQ. Has relative maxima at these points because we said the reason why, and our definition is the derivative. We have to be specific because if you just say it changes, they will not take that. Okay, so you have to be careful and identify what is changing. The derivative, f prime, so you can either write out the word or just put f prime, because the derivative, f prime, is, or changes, from positive, or you could put a plus, to negative, or you could put a minus. That's our reason. The reason is that the derivative changes from positive to negative. That's what tells us that there is a maximum. Okay, so let's look at C. For what values of x, so we're looking at x, is the graph of f concave down? So remember, that's talking about our second derivative, but we don't have our second derivative here. We have our first derivative. So let's clear off what's happening so far. And we are looking for where f is concave downward. Concave downward happens where the slope of the derivative is negative. So where is this graph that we see? Where is the derivative decreasing? If we're going along, then we're going up, up, up. At this point, we start to go down. So if we follow the graph, we're going down, and then we're going up again. That's increasing, and then starting here, we're going down again. So C, what values of x is the graph concave downward? You can write your answer in two ways here. You can either do an interval, which would mean you're using parentheses, so from -3 to, and then it stops at 2. And then it's decreasing again, 6. And then that's usually when we'd say infinity. But remember, if we look back up here, we're only looking from 10 to 10. So we're going to stop at 10 instead of going all the way to infinity. Sorry for my computer. Okay. Or you could write it as an inequality. You could write it like this. So we would have -3 x and 2 and 6 x and 10. So that would mean x is in between -3 and 2, and x is in between 6 and 10. So either of those you can write. So in these intervals, f, so the original is concave down because the derivative, f prime, is decreasing. So be careful with when you say positive, negative, decreasing, increasing, because those all mean different things. So you have to be very clear on that. Okay, last part. Let's erase what we have on our graph so that we have room to write. It says that suppose f of -1 is 0. Draw a sketch that shows the general shape of the graph from -4 to 0. So for this one, all we're looking at is -4 to 0. So we're only looking at this part of our derivative. Okay, we need to draw a sketch. So I'll go ahead and do part D up here, actually. So D, we need to draw a sketch, so I need a grid. Remember, we're starting at 0. Let me move this up a little bit. So here's our grid for, X and Y axis. Starting at 0, we need to do -1, we need to talk about -2, -3, and we need to go to -4. So let's figure out, what did they tell us? They told us f of -1 is 0. So at -1, we have a point that is 0. So let's think about either side of this. So we've done that. On the left, over here, our graph is all positive. So our derivative is positive. So our graph is increasing. Remember, that happens from left to right like you're reading a book. So from -4 to 1, it is increasing. So it's going to be going up to that number. And then it goes below from -1 to 0. So that's going to be decreasing. Now let's make sure that we have the concavity correct. We might have to erase this a little bit. Let's look here. Our derivative changes from increasing to decreasing. And we said that's when our concavity changes. So it is concave up on this side of -3 and concave down on this side of -3. So let's make sure that our graph represents that. So here's -3. Our graph needs to be concave up, so kind of curved up on that side and kind of curved down on that side. So there's what it generally looks like. There's a rough sketch, concave down, concave up, increasing, decreasing, of our original graph on that interval. And now we have answered all parts of this question.